Okay, hello everybody, and we are finally at the fourth and final installment of 20 integrals. Now, maybe depending on how many more integrals I can find, and of course find time to record, I might expand this to 50 or even 100 integrals as an extended series in the long term. But for now, we'll just stick to these 20 because I hope that in my selection of these 20 integrals across 4 episodes, I have successfully covered all the types of integration that you need to be familiar with in H2 mathematics. Okay, so our first integral today, I've written out the entire question because it's actually pretty long. As you can see, this was from an old NJC paper, and they directly tell you what to do. Okay, so they're trying to help you here. They say they want you to express this part here, x squared plus 1, as this particular expression, and therefore evaluate. Now, this original question was actually only 5 marks. And once again, it's a paper 2 question. So you will remember what I said earlier when we were doing, I think the JPJC question, was it? Yeah, from the previous part 3. And I was saying that paper 2 pure maths is usually harder than paper 1 pure math. Yeah, we are going to see another example of that in this integral. Okay, so the first step, of course, is to express x squared plus 1 this way. So I'm going to take you through step by step, okay? Let's say I want to express x squared plus 1 as this form, right? So I'm going to expand and then I'm going to compare coefficients. Okay, so let's start from the right hand side. I'm going to expand this bracket now, and I'm going to write x squared plus 2x plus 1, and then plus bx plus b plus c equals to x squared plus 1. And I can expand this further and start to compare coefficients, right? So you see that I have all the terms for x squared here. I have all the terms for x here. I have all the terms independent of x here. So by inspection, or by comparing coefficients, you can see that a equals to what? A equals to 1, correct? I hope that's obvious. A equals to 1. And then because 2a plus b, on the right hand side, there are no terms independent of x. I forgot to write that. So on the right hand side of this line, the second line, there are no terms independent of x, which means that these two, 2ax plus bx, 2a plus b equals to 0. So if a is known to be 1, this means that b has to be minus 2. And now I know that 1 plus minus 2 plus c equals to, what's my term independent of x on the right hand side, is equals to 1. So therefore c is going to be equals to 2. Okay, I hope that's clear. And so therefore just follow the instruction. Okay, if there is an otherwise way to do it, they will tell you or otherwise. But unless you take further math or H3 math or math Olympiad or a combination of those three, please do not do the or otherwise unless you want to die lah. Okay, so therefore this means that we can express this thing in the yellow highlighted part this way, right? So I'm going to copy this over. I'm going to break this down. So this thing, I have expressed it, is equals to ex, and then I replace with my a x plus 1 squared plus bx plus 1 plus c. So I have found that a is just 1, so it's just like that, minus 2 x plus 1, and then plus 2. Correct? Yeah, correct. So that's the fraction. This yellow part here, I have expressed it. And then, of course, I need to add the integral. Okay? Now, why have they asked you to express it this way? Because you see that what I have done, I think I showed you this before, earlier somewhere. Yeah, in the previous, hang on, was it in the previous? Okay, one of the past integrals, I can't find it right now. Basically, I showed you the split numerator method. So you have a very, very scary term in the numerator that looks to be unintegratable. I'm going to split that term and express it as the sum of multiple smaller terms, such that I can split this integral up into a few smaller integrals. So this is essentially what I've done here, is the split numerator method. I forgot if I did this in episode 3 or 2, if I remember, I will put in the description where I did this so that you can cross-reference, okay? So, we can now express this as a bunch of smaller integrals, right? So this is going to be, because I have over here x plus 1 squared, right? So you see what is going to happen here and here. Hang on, let me change this to a line. Okay, here and here are going to cancel, which means that this first term here is just ex dx. You follow me so far? And the second one, okay, I'm expressing it as minus 2 ex x plus 1 over x plus 1 squared. So this x plus 1 term and this x plus 1 squared term are going to cancel. So my second term is just going to be ex in the numerator, and then x plus 1 no squared in the denominator. Okay, and then this one got nothing to cancel lah, unfortunately. So this last one is just going to be 2. As you know by now, I do not like to have a constant in the integral, so I take any constants out of the integral. And this one no choice is nothing to cancel, so the bottom is x plus 1 squared. So I split it into 3 smaller integrals, but at this point, you still might think, hey, how on earth do I evaluate each of these 3 are? The way that the question needs you to approach it is not the conventional way of approaching integration. So far we have been doing integration from the top down, right? You just write the integral that equals. Now I'm going to show you that you can also do a bit and then sidetrack a bit and then come back. What do I mean? Let us consider just this integral in the middle. Okay? So let us consider only this particular integral. No, let me put it in a nicer color. Okay, let us consider only this particular integral, okay? Hang on, I don't want the 2, just this particular integral. So I will only consider, for now, this integral in the middle. Okay? So how am I going to solve this? This, it's not very clear right now, but if I write it this way, okay, I'm going to take the ex out and I'm going to 1 over x plus 1. And think about it, right? Can you solve this using integration by parts? Yes, you absolutely can. You know how to integrate this? Good. You know how to integrate or differentiate this? Good. Perfect. So we can just do integration by parts. So I'm not going to go through the full procedure for integration by parts by now because you should be very, very familiar. But basically, LIATE, right? So where is my U? This is going to be my U, which means that U prime is whatever the derivative of this is. So I will differentiate this. This one, 我不需要 integrate. Okay? This one, my V prime or my dV is EX. So my V is just going to be EX. So if I try to integrate this by parts, this is just going to be UV minus V du. So if my U is 1 over x plus 1, so this is my U, I want to differentiate 1 over x plus 1. So this is just going to be minus 1 over x plus 1 squared. And I hope this is clear to you because I can just write this instead of the reciprocal like this. I can write it as x plus 1 bracket whole thing minus 1. So if I try to differentiate this, right, then this minus 1 power I bring down, and then after that this thing is going to become power minus 2. That's why my minus 1 power I bring down here, and then this thing power minus 2, because 1 over x plus 1 squared in the reciprocal is just this power minus 2. Understand? So I hope that's clear to you. And then we are going to continue to integrate. So we are still just on this blue one first. We'll get back to the main one later. And I can just express this as ex over x plus 1. I have 2 minuses here, 1 minus here and 1 minus here. So this will become plus ex over x plus 1 whole thing squared dx. And you may be tempted to do another round of integration by parts here, but you do not need to. Just one round of integration by parts is enough. Okay? 通常如果分数不太高的话，你通常只需要做一个 substitution 或一个 integration by parts，应该不需要会做超过一个，在一个5分题之内，OK？所以let's go back to the this integral now, and you see that this thing over here, my ex over x plus 1 whole thing squared, is this particular integral, okay? So we can incorporate it somehow, right? This means that therefore we can write it as this integral I don't need two therefores. This integral, okay, is going to be, let me just erase the highlighter. Okay, this integral is going to be equals to our first integral minus, okay, ex over x plus 1 dx. I have established that it is ex over x plus 1 plus this orange integral here, okay, and then after that 再 plus 两个那个橙色的，所以总共这里有一个橙色的，这里有两个橙色的，所以总共有几个？3个橙色的，对吗？OK，so 这就是说我们在这里应该写成，诶 did I leave something out? Okay, I'm so sorry. This should be yeah, because there's a 2 here. I'm sorry. 这里应该必须有个2 ，OK，所以总共在这里有两个橙色的，这里再有两个橙色的，所以总共有3个 ex over x plus 1 squared，OK？So I'm sorry for that. We are going to integrate now. Integrate ex with respect to x is obviously just ex, correct? And then this is going to be minus 2 ex over plus 1 minus, oh no, I'm sorry, this one is minus 2 of this orange one. This one is plus 2 of this orange one. So this and this is going to cancel. So all I'm going to have is just this. Yeah, I think that's all. Yeah, I think that's it. Wait, I'll just make it clear for you. Because this is minus 2, right? So minus 2 of, no, I shouldn't cancel the minus 2. Minus 2 of this, and then plus 2 of this, cancel. This is all I will have. And then, of course, no more integrals. I have to write a plus. C. Is that it? Yeah, I think that's it. We're done. Okay, so I know I probably took some time on this integral. The next couple of integrals are going to be, I hope I will make fewer mistakes. Yeah, it's not even 8 p.m. Yeah, I shouldn't be making so many mistakes. I'm sorry. Let us go now to integral number 17. So this integral actually asks us to find a very interesting function. So that's why I wanted to show you guys this one, okay? So this one asks us to find a definite integral, and it's the following. And the modulus is in the power. So this is the first time that I have showed you integration of modulus functions in this series of 20 integrals. And before I go on to the question proper, I am going to show you a brief introduction to how to handle integration of modulus functions. Okay, so I'm going to move this to the side a bit. Let's say I want to integrate a very simple modulus function like y equals to mod x squared minus 1. And let's say I just want to find the area from root 5 to 1. Now, the reason why I have drawn this as a dotted part here is because if I don't have the modulus, so for a moment, I'm just going to imagine that this modulus is going to go away, this modulus is going to go away. Okay, then this solid part plus this dotted part, it's a quadratic curve, right? This is indeed my curve of y equals to x squared minus 1. So this is going to be minus 1 here. But if I add a modulus, then we learn in Sec 3, right? If I add a modulus, then instead, this thing is going to come up here. It's going to be reflected. Anything below the... So that's a bit ugly, sorry. Yeah, anything below the x-axis is just going to be reflected upwards. So this is going to be 1. So if I just want to find from... Sorry, this should be root 5 to 0. If I just want to find the area of root 5 to 0, not only do I have to consider this yellow shaded area under the curve, I also need to consider this blue shaded area under the curve. So I shade this a bit more finer. So the yellow shaded area, the yellow area under the curve, plus the blue area under the curve, I need to split this into two integrals, right? So this is going to be root 5 to 1 of x squared minus 1 dx. Okay, so this is the yellow one. But then to find the blue area, okay, to find the blue area, I need to take from my 1 to 0. And I cannot take x squared minus 1. I have to take negative x squared minus 1. Because you remember we learned in chapter 2, under graph transformations, if I reflect about the x-axis, it's what? It's minus in front here, right? So that's why when I'm integrating from 1 to 0, I need to add a negative sign in front. So this is my blue shaded area. 所以这黄色的跟这蓝色的总共就是整个 shaded area. Then we can integrate this separately with respect to x, which is just going to be don't need to copy this now. This is tangential to the video. This is just to show you how to integrate a modulus function. And then minus, yeah, minus. And then I'm sure you know how to integrate from here already. So dot dot dot, etc. Okay, you can go and work this out yourself if you want. But basically, my point of showing you this little side quest is to show you that the way you handle a modulus function in integration in general is to remove the modulus by expressing it as two different integrals. So, sorry, just went to have a sip of water. So, if I want to apply this now, you can use your GC to sketch the curve. I'm using my iPad, so I can't show you the GC now. In some of the other math videos, I do use the online TI-84 to show you the GC. I'm sorry I can't do that right now. But basically, if you try to plot using your GC, right, you will see that the place where this curve, okay, so you just input this entire thing into your GC, you will see that the place where this curve touches the x-axis is where x equals to 2. So what do I need to do? I need to split this up, right? Because from 2 to minus 1, okay, this is just going to be x e 4 minus x squared, okay? I wish I had the GC so that I could show you, but you can just use the GC, sketch this curve out yourself. If you need to in the exam, also just sketch the curve on paper, please, to make it anything to make it easier for yourself, and you will see what I mean. It's analogous to the example I just showed you, where I did sketch the curve out for you. And then, after that, the remaining area is from 3 to 2. And this part, if you use a GC to sketch, you'll see is actually below the x-axis. So when I'm resolving the modulus for a part that is negative below the x-axis, this one cannot be 4 minus x squared anymore. This one needs to be x squared minus 4 is the negative of that. I hope that makes sense to you. And then from here, I can actually integrate. So what I'm going to do, I'm going to show you something, okay? We are going to take a... Okay, we're going to take something out. I will show you what that something is later. And I'm going to rewrite this expression here. I'm going to rewrite it as follows, okay? I'm going to rewrite it as minus 2x e power 4 minus x squared dx. Okay, why is this? Because one of your standard forms, I hope you remember, is as follows. When you have a function f prime x e f x dx, and you integrate this, this is just equals to e f x plus c. So I think we've seen this a couple of times in episodes 1 and 2. I'm trying to take some kind of constant out. Then only I can rewrite what's inside the integral. into one of the standard forms. So if I change this x to minus 2x, 外面我需要放一个 minus half 对吗？对 minus half. Okay, and then here once again, if my fx is here, I want to write this as f prime x. So if my fx, this on power of the e is my fx, I want to write is x squared minus 4. So this one obviously needs to be 2x, correct? That only is in the standard form. And then if I have x here and I want to change x to 2x, this one needs to be a positive half. Okay, so from here I can use the standard form already to integrate. I think I'll bring this a bit closer. This is the standard form that I want you to use. And if I use this particular standard form that I've written in green, I can actually express each of these. Okay, I can express this one as this is going to be minus, it's just minus half, then EFX plus C, but there's no plus C here lah, because it's a definite integral. And then likewise, half, this term just completely disappears. So just EX squared minus 4. Okay, and then you can sub in. If you sub this in, you will eventually get the following answer. Okay, check your answer, pause the video to check your subbing in if you have to, but you should somehow get half e cubed plus half e power 5 minus 1. Okay, in the interest of time, I'm not going to show you some things. We still have 3 more integrals to cover, and I'm getting tired. Okay, I'm sure you're getting tired too from listening to my voice for, I think all 4 episodes combined might be about, what, close to 2 hours, maybe slightly more than that. Okay, so let's go on to the next integral, integral number 18 of 20. And this one is even more interesting. Okay, this integral looks very, very simple. By the way, the one on top was 3 marks, okay? All that for 3 marks. The one on the bottom is 4 marks. This 4 mark integral looks as follows. And that's all. So what's your first instinct? Remember I showed you before somewhere, I don't remember where, I'm so sorry. If you have an inverse trig, you can actually express, yeah, here, number 6. I said if you just have one function inverse trig, I can express it as 1 times something and then apply integration by parts, right? We can do something similar here, not exactly the same, but also similar for things like inverse trig and log. Because think about it, right? LIATE. A, T, and E, we learn a lot of rules to integrate. Inverse trig and ln, have you learned any rule to integrate ln or not? No, right? So that's why we need to resort to things like that. So the approach is going to be integration by parts. So I can express this, actually, no, it's not almost the same thing. It is the same thing. So I'm just going to write this as 1 times ln x squared dx. Now, I've gone through integration by parts a lot of times. I'm not going to write out the full u, du, v, dv anymore. Okay? Just know that this one is dv or v prime if you prefer. This one is u. So obviously du, actually never mind, I'll just write it out. Du dx or u prime is going to be, if you differentiate ln x, I can treat this as power rule. So I can power rule this, and then I chain rule it by multiplying it by the derivative of ln x. So that's going to be 1 over x. Okay? So if I integration by parts this thing is going to become, if dv or v prime is 1, then v is just going to be x lah. I hope that's clear to you. So this will just be x, and then I keep my u minus two. Yeah, because this, okay, I won't skip steps. Okay? So u v minus, or rather u v minus v du, and du dx is 2 ln x over x. Yeah, so I fumbled just now because I was about to skip steps like I normally do, then I realized this is a video I better show you. So obviously 这个跟这个会 cancel，所以最终这里只有一个 2 ln x. Okay, so that's going to be x ln x, this ln x whole thing squared minus, I'm going to take my constant out, and you see that this ln x dx, I can apply integration by parts one more time, right? Because I can just express this as 1 times ln x, and then I can apply the same thing all over again. So I will leave you to figure out how to do that. But basically, yeah, I'm skipping a lot of steps now because this is the 4th episode. We should be a lot more familiar with this math than we were at the beginning. So there are some things I'm not going to show you. I'm not going to hold your hand as much as I did 4 episodes ago anymore. This is going to be... So if I integrate ln x by integration by parts, this is going to actually be x ln x, because I integrate by 1, I get x, I keep the ln x, minus, I just want to integrate x and then 1 over x. So x and 1 over x cancel, this will become 1 dx. Hope that makes sense. And then this will simplify to 2x ln x plus 2x plus, yeah, plus c. And we're done. So this is a rare question where it's 4 marks. They ask you to apply integration by parts twice in 4 marks. Okay? But you see that actually a lot of steps are quite skippable. I'm sure by now, having been through integration by parts many times, you'll see, even though I've skipped a lot of steps, why this follows from this red part. Okay? I hope it's clear to you. I was about to say, if it isn't clear, please stop me, but then I realized, yeah, watching this video God knows when, so you can't stop me if you're not clear. But yeah, please do leave any questions in the comments. I'll try to answer them, if any. Okay, even though I know it's a pain in the ass to type math out, especially on YouTube. I'm not sure you can type math notation out on YouTube, but I'm sure there's a way lah. Anyway, I've wasted enough of your time. Last 2 integrals. Both of these are from a former RIJC or RJC in those days paper, and both of these are very old questions from 2002. So the first question, set by our friends in Bishan, says integrate the following. So by now we've been through 18 integrals. You should have some kind of pattern recognition skills by now. We've been through trig identities a lot. Can you think of how to integrate this? Or rather, can you think of how to simplify 1 plus sine 2x dx using our trigonometric identities? You thought of it yet? Basically, by our double angle formulae, this thing is just going to be, I can express 1 as what? 1, I can express as sine squared x plus cos squared x, right? Now, it may seem counterintuitive to you to have to express 1 as something else, but you will appreciate why I need to do this later. Okay? And the sine 2x can express it as, we know our double angle formula for sine is just 2 sine x cos x. Okay? Do you start to see the vision already? I hope you do. This is your 19th integral. At least the 19th integral in your life. I hope it's not. But if it is, I'll be very honored. Basically, if I express it in this form, then do you see that it's just a quadratic form, right? I can just refactorize this into sine x plus cos x squared. Because my usual algebraic identities still apply for trig, okay? So, that's it. And then, at this point, you still might seem stuck. Okay? The way to do it is to notice a lot of our integrals are in either you solve by standard form, or you try to integrate somehow tangent x secant squared x, all that. Because we know how to integrate secant squared, right? We know how to integrate sine and cos. So, how I'm going to express it as follows are, this question I admit is not easy, 真的很难. when I first tried this question on my own, I got stuck at this step. I got stuck here. I didn't know how to do until I saw the answer key. So I'm gonna handhold you a bit more here, okay? This one, what they want you to do is they want you to express as follows. They want you to write like that. Because only when you try to force out a sine x over cos x, then only you can get a tangent. Because I want to find secant or tangent, which is easier to integrate. And just check very quickly that simplifies to the same thing, right? Because the cos x is this one times 1, sine x is this one and this one cancel. Yeah, it's correct. Yeah, the hard part is not the math. When you read the answer key, you understand perfectly how to do the math. It's just that it's hard to think of how to go from line 2 to line 3. Okay? And for all of that trouble, the question only gives you 4 marks. So I'll be honest, if you get this question in prelims or A-levels, writing line 1 and line 2 will get you 1 mark already. Just take your 1 mark and move on, okay? So, if I have this, then I can actually split this up into a product of two integrals, right? Because this is going to be 1 over cos x squared, or cos squared x, times this one over here is tangent x plus 1. Tangent x plus 1 squared tangent x plus 1 squared is just going to be, I can express this as tangent x plus 1 power minus 2. Remember, when in doubt, express in the negative power. So obviously, this 1 over cosine squared x is going to become secant squared x. Finally. Now, after a lot of manipulation, I finally find something that looks like I can integrate it. And then this one is 1 plus, 1 plus tangent x minus 2 dx. So do you see that this is actually one of our standard forms that we are familiar with? Because in this case, this is my f prime x. No, this is my fx power n. Okay, wait, I don't think it's clear to you. When I have integrate f prime x, fx over n, you remember one of our favorite standard forms. This standard form is just going to be equals to fx n by plus 1 over n plus 1 plus c. Do you see that this that I've written here is in this standard form? Take a moment. If you don't see it, take some time to see it, but I hope you do. Now do you? Fantastic. So yeah, this is in this particular standard form here. So I have tried to convert it in terms of secant and tangent so that I can force it into this standard form. Okay, yeah, this question is really not easy because just to get to here is already quite a hard feat. Just to write these 3 lines, line 3, line 4, and line 5, the amount of out of the box thinking is quite high order one. So if you've gotten to here, congratulations, you should be very happy because I can just use the standard form. This is just going to be, because this was originally power minus 2, this will be IO minus 1 over minus 1 plus c, and I'm going to tidy this up because I don't like to leave my answers this ugly. I'm going to, 1 over 1 plus tangent x plus c. Okay, so yeah, this was really not an easy integral. I've left the best for the last. And finally, for the last integral, for now, we are going to do another 4-mark integral from a very old RI/RJC paper. So for our last integral in 20 integrals, we are going to look at one final integration by parts question. First impressions of this question? Anyone? You will see, or rather my personal first impression of this question, is that you see a lot of things that you feel you can either integrate or differentiate. So you know that 这一题是我应该可以做的 but 做的时候 of course the amount of tediousness is quite a bit lah. So most important, when you see this kind of question with a lot of familiar expressions, don't throw away your precious 4 marks, okay? Be slow if you have to. Sometimes you can afford to slow down because you really don't want to lose anything, okay? So this one, I'm going to write out everything for integration by parts because I feel it's important too, okay? So I'm going to have LIATE. No, this is going to be my V, or rather dV. This is going to be my U. Because remember, I rather differentiate an inverse trig than have to integrate an inverse trig. Okay, so if my U is this, then my du dx is, if I use the standard form in MF27 and then I chain rule. Because in MF27, we know that we are given in MF27 how to differentiate tangent inverse x, right? So if I apply this result that is given to me in MF27 and then I chain rule it, I will get the following. It's going to be 1 plus this thing squared. And then I chain rule it, I still need to multiply it by the derivative of 1 over x plus 1. We did this earlier, right, in number 16. The derivative of 1 over x plus 1 is as follows. Okay, and v prime or dv is x, so v is I integrate x squared over 2. Okay, so I hope you see the vision. Let us integrate. So I sub in v u minus this abomination of an expression, which I can tidy up. It starts with a minus sign, and then I have 1 over x plus 1 squared plus 1. Did I clean that up correctly? I think I did, yeah. And then times x squared over 2. Yep. And now let's integrate. So if I'm just going to copy this over because I'm lazy. I am going to, okay, I'm going to choose to take this half here out. I'm going to take it out. And I'm going to express this as just x squared over x squared plus 2x plus 1 plus 1x squared plus 2x plus 2 dx. So, remember at the start of this series, integrals like this with fractions used to look quite scary, but now they're perfectly manageable to us, right? I hope you see the vision now, and I hope you see how much we've improved mathematically over the past 4 episodes, such that this, we recognize it as simply, oops, this should be a plus, I'm sorry. We recognize this as simply being able to solve using partial fractions, right? So, no, I don't need partial fractions. I can just take a 1 out. Yeah, I can just take a 1 out, and this will become 2x plus 2 over x squared plus 2x plus 2. And how do I integrate this fraction over here? It's just a standard form, another standard form that we know and love a lot. Isn't it? This is just going to be half. I integrate 1 with respect to x, I will just get x. And then if I want to integrate this fraction because it's f prime x over fx, I will get ln. Do I need to put a modulus? No, right? Because x squared plus 2x plus 2 is always positive. So I can put the modulus, I can don't put the modulus. I personally, personal practice, I just put the modulus anyway. It is always positive, right? Yeah, it is. But personal practice, I just put the modulus anyway. Are we done? Yes, I think we are done. Okay, fine. I'm just going to expand that just for peace of mind. Plus x over 2 minus half ln x squared plus 2x plus 2 plus c. And that is it. So I've done a lot of integration by parts. I've done some integration by substitution, and I've showed you a lot of methods, including how to do integration by substitution for indefinite integrals, definite integrals, integration of modulus, and all that. So I hope that you've enjoyed these past 20 integrals, and hopefully we'll see how things go. Hopefully we may meet for more integrals in the future. So thank you very, very much for being with me, and yeah, take care.